Okara, soy pulp, or tofu dregs is a pulp consisting of insoluble parts of the soybean that remains after pureed soybeans are filtered in the production of soy milk and tofu. It is generally white or yellowish in color. It is part of the traditional cuisines of Japan, Korea, and China. Since the 20th century, it has been used in the vegetarian cuisines of Western nations. It is called duza or dufuza in Chinese, okara in Japanese, and biji or kongbiji in Korean. Okara is the oldest of three basic types of soy fiber. The other two are soy bran, finely ground soybean hulls, and soy cotyledon, isolate fiber, the fiber that remains after making isolated soy protein, also called soy protein isolate. Production. Okara is a food byproduct from tofu and soy milk production. In 1983 it was estimated that the annual yield for okara in Japan was approximately 70,000 metric tons. Due to its high moisture and nutrient content, okara is highly prone to putrefaction, and this has limited its commercial use. Composition. Okara that is firmly packed consists of 3.5 to 4.0% protein, 76 to 80% moisture and 20 to 24% of solids. When moisture-free, the gritty okara contains 8 to 15% fats, 12 to 14.5% crude fiber and 24% protein, and contains 17% of the protein from the source soybeans. It also contains potassium, calcium, niacin. Most of the soybean isoflavones are left in okara, as well as vitamin B and the fat-soluble nutritional factors, which include soy lecithin, linoleic acid, linolenic acid, phytosterols, tocopherol, and vitamin D. Okara contains some antinutritional factors, trypsin inhibitors mostly destroyed by cooking, saponins, and soybean agglutinins, which cannot be easily digested. Fermentation, by proper species of bacteria, of okara is conducive to digestion and absorption of okara nutrients, and it further improves the nutritional value. It can eliminate the bean's odor, increase the amount of edible fiber, free amino acids, sugars, fatty acids, vitamin B12, vitamin B2, and flavoprotein. Uses. Most okara worldwide is used as feed for livestock, especially hogs and dairy cows. Most of the rest is used as a natural fertilizer or compost, which is fairly rich in nitrogen. A small amount is used in cookery. Human consumption. In Japan it is used in a side dish called unohana, which consists of okara cooked with soy sauce, mirin, sliced carrots, burdock root and shiitake mushrooms. Okara can be used to make tempeh, by fermenting with the fungus Rhizopus oligosporus. Using a tempeh starter, it can make press cake tempeh using ingredients such as brown rice, bulgur wheat, soybeans and other legume and grain combinations. Okara is also eaten as red oncom by the Sundanese people on Java in Indonesia after fermentation by Neurospora. Okara is eaten in the Shandong cuisine of eastern China by steaming a wet mixture of okara that has been formed into blocks of zha dufu, also known as shao dufu or kai dufu. The product is sometimes used as an ingredient in vegetarian burger patties. Additional uses include processing into a granola product, as an ingredient in soy sauce and as an ingredient in pâtés. Livestock consumption. Most okara is used as animal feed, especially for farms in vicinity of soy milk or tofu factories. In pet food. The product is used as an ingredient in pet foods. As fertilizer or compost. Okara is sometimes spread on fields as a natural nitrogen fertilizer. It adds tilth to the soil. Likewise, it can be added to compost to add organic nutrients and nitrogen. Waste, environment. When not considered foodstuff, it may be deemed soybean curd residue, SCR. Some 800,000 tons of soybean curd residue is disposed annually as tofu production byproducts in Japan. As mass waste, it is a potential environmental problem because it is highly susceptible to putrefaction. The protein in SCR is of better quality than from other soy products. For example, the protein efficiency ratio of SCR is 2.71 compared with 2.11 for soy milk. The ratio of essential amino acids to total amino acids is similar to tofu and soy milk. Nevertheless, it remains a challenge to current processes to commercially extract the proteins and nutrients from SCR waste. See also: Food portal. References. External links: Ellen's Kitchen, Okara Tempeh, Okara Mountain, recipe blog, Okara Project, recipe blog.